It's streaming to YouTube, the serverless land YouTube, if you're familiar with serverless land. So it'll be streaming there, and it's streaming to our LinkedIn, to the serverless land LinkedIn. So by way of that, I'll kind of tell you who I am and why I even can serve there. And my remote's not working, of course. It came up, so we'll just do it the old-fashioned way. That's me. If you don't know what I look like, that's what I look like. So my name is Eric Johnson. I'm a principal developer advocate for serverless. And when we talk about, are you smart in an area? Probably in serverless, I know serverless. Other areas, nope, dumb as a brick. So we all have our specialties, right? And so serverless is mine. I live, eat, and breathe that. That expands into what we call event-driven architecture, or EDA, where you get into distributed applications, distributed data, things like that, where we use serverless. But today we're going to, sorry, do you want me to? So, all right, I'll stop walking around. So Brian's trying to keep me in camera. There we go. So today we're going to talk about building a domain-specific GenAI chatbot with serverless. And there's some things about that we'll get into. First of all, I'll finish telling you who I am. Again, I'm a developer advocate. I'm a solutions architect. How you doing? Architect for 15 plus years. They pay me to speak at AWS. It's shocking, isn't it? Like, why are we paying him? So that's why I don't record often. Software developer for 30 years. I'm pretty old. There's a couple, real quick, I'm going to pause for a minute and explain some things. There's a couple of rules when I'm talking. Okay, rules is probably strong. Maybe guidelines. Has anybody ever heard me speak before? Okay, a couple of you. All right, do you know the rules? All right, you know the rules? Okay, well, I'll tell everybody else the rules. These help. All right, the first rule is this is any number I want it to be. Okay, I'm going to hold this up. I'm going to say 30. I'm going to say 12. I'm going to say 392,000. I'm the only person that gets it right. Okay, the second rule is these are quotes, not apostrophes. I know that. This looks a lot better than this. Okay, so I do that a lot when I'm talking. And finally, these are thumbs because this will get you beat up. Okay, so that's how it works. I did not wake up this way for the first time. I do have one finger in each hand. I have one toe in each foot. I was born that way. If this was the first day I was like this, I don't like you that much. I wouldn't be here with you. Okay, I would be somewhere coping, right? So I do make a lot of one-finger jokes. I'm very comfortable with that. If that makes you uncomfortable, I'm actually comfortable with that as well. So I'm good. So today we'll have some fun. My Diet Dr. Pepper, if you know anything about me, this is pretty much all I drink. It's not good, but there it is. All right. Yeah, we all have our vices. I am a father of 5. That's not a typo. And sometimes I wish it were, but there it is. We have a crazy household. Tells you how amazing my wife is. And I'm a GenAI enthusiast, you know. But in these days, who isn't, right? Because we're all kind of, I got to learn that, I got to learn that, right? I don't claim to be an expert. You may talk to me about the algorithms. Like, I can't even spell algorithms. I don't know, right? I can't count past 2. I can get to 4 with my shoes off, but that's weird for everybody, right? So I don't do the math part, but I do understand GenAI in the scope of serverless and in the scope of operations. That's kind of what we're going to show today. So here's what we're going to look at today. So we're going to talk about some terminology, just so we're kind of all on the same page. Probably everybody knows it already, so bear with me. But just making sure that we're on the same page. I may not even be right, but you'll know what I'm talking about, right? Second thing we're going to do is our architectural options that I had. Why I made the choices I made, okay? The third thing is we're going to live code, which deserves a, live coding is always fun. I love live coding, and I have had to live code with no internet tethered to my phone at a reInvent from Las Vegas where everybody else was using their, it just gets crazy, but I like live coding. I will tell you this, I have one finger in each hand. We've already covered that, but I'm still the worst fat finger on the planet, okay? So we'll see how that goes. Finally, we'll do a wrap. The live coding, we're going to show a demo, obviously, of what we're doing. Now, I'm probably going to be sitting down for most of this because there's not really a place for me to stand up and code, so bear with me as we do that. But let's get into terminology real quick. First of all, we're going to talk about generative AI, right? There's a lot of definitions out there. People define it differently. This is how we look at it at Amazon. Generative AI is AI, and this is an interesting one here. It's AI that can produce original content close enough to human-generated content that for real-world tasks, right? We're not saying it is human, but man, it's coming closer and closer each day, isn't it? My mom calls me once a day. We got to shut this down. Well, it's out of the bag, Mom. It's there now. So. It's powered by foundational models. We'll talk about that in just a minute. Tasks can be customized. There's a lot you can do with them. It's applicable to Many use cases. A lot of times we're just doing text, but we're getting more and more and more. I was actually using one of the AI foundation models the other day, and I was trying to figure out how to do some CSS, because nobody's good at CSS, right? I mean, maybe there's a couple, but I'm not. I can't even spell it, right? And so I was trying to figure out this layout, and so I would tell it, this is what I want, and then it would generate CSS, and then I would copy a picture and drop it in and say, that's what you did. Is it right? No, it's not right. Let me check it. So it's very powerful. It's not just text. It's image evaluation. It's lots of different things. It's really kind of endless on what we can apply it to, both good and bad, right? And it reduces time and cost to develop ML models. It just reduces time in general. I was in Vegas a couple of weeks ago, and we were presenting. I actually did a project for the NFL, and we were presenting a project where we took something they were doing by hand. They were doing image manipulation by hand. And they were hiring, there's a lot of players in football, so I heard. I'm not really a sports ball guy, but my kids tell me there's a lot of players in football, right? And this is American football, right? And so they were editing all these images by hand, and they were sourcing it out, and different groups were sourcing it out. And it ended up, they were paying about $47,000 a year to have this done. And they were doing it by hand, and it was taking several weeks. So we sat down and said, okay, tell me what you're doing. How can we do this? So we sat down, and I'll talk about the project later if you want to hear questions about that. But we figured out a way using Adobe APIs and some of our own AI ML and generative AI. And we brought that time span from 3 weeks down to roughly a minute and a half. And it cost them about $400 a year to do. So this go-to-market and this ability to do things fast and build proof of concepts is really quite powerful. And today I'm going to actually kind of build some stuff using serverless. This is why I love it so much, because serverless is this idea of how I can I can prototype very quickly. If you're not familiar with serverless, I won't go into too much to it today, but I'll kind of explain what I'm doing. So, all right, so real quick terminology. Foundation model or LLM, they're called both or different things. But I want to talk about kind of the difference. This top one is the conventional ML flow, where you have data, you do some pre-processing of the data, you do task-specific model training, you do hyperparameter training, and then you get your model, you validate it and test it, and then you use it. And as you're running iterations against it, you retrain. Use it, retrain. You train it for very specific things, right? Like recognize this image and find the face, right? And the way this works is you just train it, you continue to train it until you get it fine-tuned, and it has a task-specific deployment. A foundational or LLM model, we'll call it foundational, same thing, but it just takes, well, not same thing, it's actually quite different. It takes a ton of data. You just fill it up with data, right? Okay, and then you pre-process that data, you get it all kind of formatted, and then you do the training on the foundational model. And then what you're able to do is you can use this for different task-specific or ideas. Okay, now major difference between ML or AIML, how we used to use it, and the foundational models is one is deterministic, meaning you put the same thing in and you get the same thing out almost every time, right? There may be some variance you have, but pretty much. The other is stochastic. The only reason I have that up there, I was telling Brian, is because I had to look this up. I don't even know what that means. But this, I do know what it means. It means that you get variable answers, okay? A foundational model is going to give you put the same thing in, you get different things back. And one may be more righter than the other till you get to the rightest or correctest or however that word is. So that's kind of, if you understand the difference between, or in foundational models, how those work.
Is there a difference between non-deterministic and stochastic?
Non-deterministic would be also stochastic. I just wanted to use stochastic. Please don't burn me on that, all right? I was very proud of that. He needs to go.
All right.
Yeah, it's not working out. We had a good run. So, yeah, that's right. It's on the list. All right, so the other thing we're going to see tonight is what we call retrieval augmented. Come on in. Yeah, come on in. Have a seat. Welcome, welcome. We're going to talk about retrieval augmented generation. Now, this is just one of many ways of kind of fine-tuning your LLM or your prompt, okay? The way I'm approaching this, I'm just using a basic LLM that you can see today. I'm using the new Claude version 3. I'm using the Sonnet version, okay? And it's kind of a middleware between super powerful and pretty quick. I won't say super quick on any LLM yet because they're not super quick, right? But we're getting there. So it's kind of this mix, right? But but we wanted to do some specific things. And if you remember, the title of today's talk is building a domain specific, meaning we wanted to have some information that probably isn't open to all the world, right? We want to build this. Maybe it's an internal thing we're building for our internal customers where it's private data. Maybe it's something else where it's not publicly known or trained, but we want the LLM to grind against that. So we can do this thing called retrieval augmented generation. And what that means is we have this processor. We won't talk about what computer or things like that yet, but we have this processor. So we make this request to the processor, and it's going to make the same request to our domain-specific data. It may be, in our example, I'm going to be using Kendra, which indexes a lot of data. It's an AWS serverless service. But it could be you could do embeddings with another model or something like that. Or you can, there's all kinds of things. You could be looking at databases, all kinds of things. You grab that information back and you insert it into your prompt. And then you say to your model, your foundational model, I'm going to give you this information. I want you to refer, and I'll show you the prompt we use for this, but I want you to refer to this data for as much of the answers you can. This is the authority. Now, that doesn't mean it'll only use that, but it starts there, right? So that's that domain specific. We lost something. We lost just the projector. That was it. So, all righty. Oh, is it back? I snapped my finger. Okay, gotcha. All right. Okay, so that's what we're talking about, retrieval augmented generation. And finally, chat history. When we talk to things, I'm sure you all use ChatGPT or Claude or something like that. When you're talking to it, you don't want to have to tell it everything you've said already, right? So you may say, hey, what is EDA? And it'll respond, this is what EDA is. And if it's using mine, it'll respond with event-driven architecture. And then you'll say, okay, tell me some services about it. Well, if you don't give it context, it won't know what it is, will it? So you have to keep a memory of your chat. And this is what happens with like ChatGPT or Claude or some of those interfaces, where you're taking the history of your conversation and submitting it again through the prompt. This is the history. This is the retrieval that we pulled. This is the new question. Do your thing. All right, so that's what I'm going to kind of show you how to build today. All right, so architectural choices. Why did I do what I do? Like any good technical question, how do I build this? The answer is, does anybody know? There you go. Well done. You may all leave. That's where we've won, right? It depends. There's always a different way of approaching things. It's just the reality of it. A lot of that is driven by what we know, right? It's going to be tonight. I know serverless. You asked me to build something on ECS, EKS, containers. I could do it, but it wouldn't be as pretty as how Brian does it, and his is bad. So, that tells you how bad it's going to be. I don't know, but I'm assuming. Right, yeah, because like your wife says, you're good at what you know. But yeah, okay. So anyway, so we'll talk about some of the architectures. Now, here were my requirements. These are the ones, there are probably some others, but these are what we're talking about. First of all, it needed to be serverless, because that's what I know, right? And I like serverless. I think you can build very fast with serverless. It needed to stream responses. Have you ever been using a chat and you sit and it spends forever, then boom, there's the answer? Does anybody wait for that? No, right? In the world today, in our world, of the way our kids and us, if I have a spinning ball longer than 2 seconds, or 5, I'll give you 5, it's broken, it's not working, right? So it has to be, I don't know why my timer's going off, but we're ready. So, all right, I'm baked. Okay, so it has to be streaming. It has to be flexible. And I'm not talking just in code. I want the ability to add and take away stuff and build on top of this, because really what I'm going to show you tonight is kind of a first permutation of this. I'm going to add some more to it. It needs to be easily secured, okay? I need to be able to put some authentication, authorization on top of that, and it needs to be scalable, all right? So one of the first things I could have done, and actually let's give you some givens. One, I know that I'm going to use Amazon Bedrock, because that's my foundational models. If you're not familiar with Amazon Bedrock, in the simplest term, Amazon Bedrock allows you, it basically is an API that gives you access to just a plethora of foundational models. Anthropic, Mistral, Titan, Llama, a bunch of different ones, right? The second thing is for my purposes, I'm using Kendra to have my have my domain-specific data. So what I've done with Kendra is I actually created an index based on serverless land. Now, if you've not been to serverlessland.com, serverlessland.com is a website that my team built and maintains that is just a wealth of knowledge about serverless. And there's a ton of that. So what I did is, boy, it's just, we're just gonna have to, no signal, it's popping in and out, but hopefully it comes back up. There it is. All right. So what I did is I indexed and I ran against serverless land and I pulled all the data in. Okay. So I had this index. All right. So architectural. So my first choice is, of course, I could have just done a Lambda function, right? I could talk to a Lambda function. I could use a function URL, and then I could have the Lambda function using the SDK talk to Bedrock and get its data back, and there we go. But in my opinion, kind of looking at this, it only checks some of my boxes. One, it's serverless. I love that. Two, it does streaming responses because you can stream from a Lambda function. Three, it's not as flexible as I want it. Now, hey, Eric, are you anti-Lambda? No, I'm not anti-Lambda, but I don't. Let's just get real for a minute. Okay, look, we'll take this out of the recording. It's going to shock some people. I'm not an amazing developer. Okay, my title is developer advocate. Big fat lie. Okay, I'm more of an architect than anything. They just, architect advocate. It's a weird alliteration. It's weird. Is that alliteration? Yeah, it is, right? Yeah. Okay. So I'm not great with grammar either. Finally, so I don't feel like it's as flexible. I also don't think it's as easily securable as I want. The two options I have with the Lambda function are to do IAM, which means I have to do signatures at my clients, and nobody wants that. That's a nightmare, right? I see head shaking right now. The second option is I have to roll my own authentication. Nobody wants that. Okay, so that's a non-starter for me. It is scalable though. It's a Lambda function. I can scale like crazy. All right. So the next option I looked at, I said, okay, what if I throw API gateway in front of that? All right. I could do API gateway to Lambda using Bedrock. Well, we're getting closer. I'm now serverless. I still have streaming, but actually, no. I'm going to change that. I don't have streaming now. I'll get rid of that in a little bit. I don't have streaming because through API gateway doesn't have the ability to stream, not true streaming. Okay, we'll kind of play with that a little bit. So if I'm using a Lambda, I can't stream. I need to delete that. I still don't have that flexibility that I want, but it is easily secured and it's scalable because with the Amazon API gateway, I can do all kinds of different authentications. All right, so let's look at another option. Well, now I'm going to go Amazon API Gateway to AWS step functions. Yes, that can be done. You can actually wire API Gateway straight up to step functions. I'll show it to you here. So this checks some boxes, but not some others, right? So now it is serverless. It does not stream. There's not a state in AWS or transition that I can stream from. However, it's easy, secureable, it's scalable, all those things. So I'm looking for a combination that gets me all my boxes. So this is what I landed on. So I'm going to use Amazon API Gateway in front. And what we're going to do is we're going to use that to get our, it's going to be serverless, obviously. It gives us our easily secured. I'm going to use my step functions. That's my flexibility. Step functions have the ability to do a lot of different things, just drag and dropping them in. And you'll see that tonight. It's scalable and it's streaming. Now, it's not true streaming. What we're actually going to do is we're going to use a Lambda function. We're going to talk to Bedrock using the streaming implementation. As those chunks come back, then we're going to send them back via WebSocket to our client. So it's kind of a faux streaming, but it gets the job done. Right, so and it actually works fairly well. So these are kind of the choices. This is kind of walk through. There are other permutations that we could certainly do, but these are the ones I kind of want to walk through. All right, so with that, I think we're going to go ahead and we're going to do a little code. So I'm going to sit down. Sorry, if I bend over, I'll get stuck that way. I did something on my back, and I sound so old right now. All right, here we go. All right. Okay. All right, so we're gonna let's code, kinda. We're gonna do a little draw or drag and drop, things like that. Has anybody worked with step functions in the room? Okay. Has anybody worked with the Workflow Studio? All right, couple. Oh, all right. Step function user. Yeah, there it is. I'm calling you out right now. Okay. I encourage you to check it out. I'm gonna show it to you today. If you're not familiar with step functions allows you to, basically you build a workflow. The cool thing about step functions is it handles a lot of your if-then logic, it handles mapping if you want to iterate through some things. It does a lot. And it does a direct integration through SDKs, right? So really, I don't have to do very much code. But let me kind of walk you through this. Now, just so you know, this is the incoming payload. This is what it looks like. It may not be who is Eric Johnson, but there's 3 pieces of data that are going to come through the API gateway that are coming to the state machine. It's just important to know as we're going through. The first is, what is the question? The second is the timestamp. And the final one is the connection ID. When you use a step function or when you use WebSockets and you make a socket connection, you get a socket ID. This is going to be our identifier, right? I'm not doing anything real extravagant. I don't have to manage topics or anything like that. I'm just doing one-to-one communication. So this is a good solution for it. If I'm doing more topics and stuff, I have other solutions. Talk to me if you need something about that. All right, so we're going to jump out of here. Let's go ahead and jump into our code. And can you all see that okay? Do I need to blow it up? Okay, good. All right. So what you're looking at here is a SAM template. Anybody use AWS SAM in the room? All right, good. A couple, okay. So AWS SAM, all this is a way to describe infrastructure, right? I'm saying this is infrastructure as code. I'm saying this is what I want to build. Now, I've preloaded it with some stuff, but I'm going to build some others and kind of let you watch me do that. The reason that this is in here is at the moment, SAM does not support WebSockets as a serverless resource, okay? So I'm actually using CloudFormation. The cool thing about SAM is I can use CloudFormation right in AWS SAM, okay? So what you're looking at here is I've got some parameters that I'm passing in that we'll worry about later. I've got the actual API. You have to create a deployment. The stage, this is like what stage I'm a prod, development, whatever. Then I've got my default route, and then I've got my default route integration. Now, right here, you don't have to memorize this, there won't be a test, but I do want to point it out just so you see it. Right here is the magic that is connecting API gateway directly to step functions, okay? This is called VTL, which stands for Velocity Templating Language. It's the best coding language on the planet. That was sarcasm, if you don't recognize my sarcasm. VTL is not for the faint of heart, but you can do some really cool stuff with it, okay? So don't, run from it anyway. But this is what's happening. You can see it's simple and easy to read, right? And you, of course, you code in escaped JSON. That's beautiful. We love that. Yeah, so, all right. And then finally, we have our route response, our integration response, and our WebSocket. That's a logging group. That's not actually part of the API. That's a lot. In CloudFormation, it takes a lot of resources to do it. This is why we use things like SAM or we use OpenAPI. Unfortunately, OpenAPI doesn't support WebSocket, or at least not an API gateway yet. Okay. With GenAI becoming such a big thing in these direct things, I think we'll see a lot of work being done on this. Okay. So what we're going to do is we're going to go ahead and start building out our product. Okay. So first thing I'm going to do is I'm going to go ahead and open. First of all, let me make sure I'm in the right branch. Okay. I'm going to go ahead and open what I call, or what everybody calls, the application composer. Now, this is kind of a new thing we put out about a year ago that allows you to drag and drop stuff. Now, it's based on SAM. Because SAM doesn't support WebSockets, Application Composer just kind of sees this as a generic resource, okay? So that's why we preloaded everything. But hey, and it's doing the light color too. We got it. We were talking. Yes. Maybe I had to restart it. I don't know, but
there's one call here. This is in your IDE.
Yeah. As soon as it comes back up, hopefully. Okay, good. This is actually in my IDE, but it's pulling from the web version. That means when they update the web version, this gets updated. So it's always up to date. So this is the app composer. What we're going to do is we're going to get into the workflow studio. So the first thing I need, we talked about the step functions is kind of going to be our hero. So we're going to pull out a state machine. So I'm going to pull it to the board here. I'm going to do a couple of details here. All right. So the first thing is we're going to go ahead and call this the ask. Oh, hey, the ask state machine. Okay. And you notice I'm going to go ahead and set it as express. I always start with express until I need standard. The difference is it's cheaper. Let's put it that way. It doesn't do everything standard does, but often you don't need it. Okay, so if I scroll down, this is just the general setting. It always pulls out one lambda. We'll get rid of that in a little bit. And then it has what are called definition substitutions. This is the same thing. This means that I can tell it dynamically a value, and then it'll insert it into the workflow when it deploys it. All right, so that's very simple. So let's go ahead and save that. Now, this is what's really cool. If you've used Workflow Studio before, hopefully you will love this. If not, just keep it to yourself. It'll be better on my ego. So I didn't build this, so but I think they've come a long way. So I'm going to go into Workflow Studio right here in my console. Okay, this is just like what you see in the web, right? So I'm going to build our application. So first thing we need to do is we need to get rid of this lambda because we don't need that lambda function yet. We'll add it later. So earlier I said we're going to build this. It's domain specific and it's content. So I need to do two things right now. One, I need to grab any history of the conversation going on, and I need to grab any data related to the question coming in. So I'm going to use DynamoDB to actually save my data. So we're going to do a DynamoDB query. Okay, and we're going to drag this in. Actually, I'm going to do one thing real time. One of the cool things you can do with step functions is I'm going to do them both at the same time. If I were doing this in a Lambda function, I would need to get one and I would get the other, or I'd have to do some funky magic, that is kind of hard. But in step functions, I can say, hey, I want you to do both these things at the exact same time. All right, so now I'm going to go ahead and drag in DynamoDB. Okay, and we want a query because we don't do scans on tables if we don't have to. That's, if you know that, you do. If you don't, I'll explain that later. So I'm going to grab a query. And then what I'm going to do is we go ahead and we say, we're going to go ahead and set it up, okay? So let me go ahead, and I do have, I'm not even going to lie to you, I totally have a cheat sheet here. So just to remember everything I want to drop in here. Okay. So the first thing, we drug in our parallels. So let's go ahead and get the DynamoDB. Now what we're going to do, this is where these definition substitutions come really handy. I don't have a table. I haven't created a table yet, have I? So what I'm going to do is I'm going to tell step functions, hey, I'm going to create a table, and I'm going to call it context table, or I may call it something else, but this is what I want to do. That's my context table. And later, I'll wire that up. That's all you need to know right now, okay? And then I'm going to go ahead and I'm going to write the key or the expression to do this. So we'll go key, condition, expression. And don't worry, if all this, typing, I'm going to do a lot of it, but I've got it if we need to bring it up too. So I'm going to say PK equals, and if you don't know what this means, don't worry about it. This is specific to DynamoDB, and it gets kind of fun. But what I'm basically saying is I want the primary key to equal a variable that I'm going to pass in. All right, so that's the first thing. Then in DynamoDB, this is just the beauty of DynamoDB. They have reserved words. So you got to always be careful of them. So we have this thing just for safety. We have this expression attribute. I can't type and talk apparently. Attribute values. Okay, and so what that looks like is we're going to go ahead and it's a object. So we're going to go ahead and say that PK. And this is important if you want to do DynamoDB. PK, there's a horrible editor here, is equal to, and it's an object also. DynamoDB wants to type everything, and this is how it does it. I'm going to say it's a string, okay? And that string, and I'm going to add something to that in a minute here. That string is going to be equal to, and I'm going to grab the $, saying this is dynamic, the connection ID. Okay, that's the $, is the root, and it's looking for that value passed in. You remember that data structure I showed? That's coming in. But I have to tell DynamoDB, I have to tell step functions, hey, this is a dynamic value. So I'm saying the string.dollar, dynamic value, is connection. Now, I'm not teaching DynamoDB here. If you don't get that, that's okay. But just kind of give you an idea of how that works. So it looks kind of ugly now. You drop out, you come back in, and there it is looking all pretty. So what's going to happen here is we're going to actually, when the step function invokes, it's going to call DynamoDB directly using the SDK. I don't have to do a Lambda function and write really bad code to make it work, okay? Yeah, I don't even have to write really good code. I just have to directly talk to it. So next thing I'm going to do is I'm going to come in here, and I told you that I was using Kendra. So we're going to use Kendra, and we want to query as well here, because we want to query the Kendra indexes that we've got, and we drag it in, and we say, at the same time, I want you to do that. So what that's going to look like is, this is actually kind of easy. So it needs what's called a Kendra ID, or that's what I'm calling it. So I'm going to use my magical, definition substitutions again. And then I want to give it some value, or I want to give it some parameters, right? So first of all, it needs to know what the query text is. So I'm going to say query text, and because it's dynamic, I'm going to do a $, and then we're going to say where it's located. And if you remember, I have it in data.message, and there you go. And then finally, we'll throw some scope around it. We'll say we only want, for page size, we only want 60 documents returned. You can get big on this. The only thing is, and that's not dynamic, that's actually, we're just going to hard code that as a number, and there you go. So that's your query. Now we'll go ahead and name these so that they're easy to understand. So this one here, this is our fetch history action. Okay, that's history of the conversation. Get rid of the query there. This one here is our fetch context, right? So we'll fetch, what am I calling that? Yeah, context, okay? So now we have a database, or we have actions, okay? So we're going to go ahead. I typed that, did not save. Let's try it again. Fetch context. Oh, okay. Yeah, Eric's messing around, didn't he? All right, so yeah. Can you imagine? So this is what it looks like one night, and I haven't applied for a job in a long time, but when you code, when you're applying for a job, and they feel sorry for you, you already typed that. Please go home. Okay, so now we'll go fetch context. Okay. Seriously. Okay. All right. Brian, I blame you. All right. So let's get off that. Now we got it. Okay. All righty. I'm telling you right now, I would be 3 times the developer if I could spell and pay attention. Okay, there we go. Whew, we got it. All right. So now what we're doing, like I said, at the same time, we're going to grab both. Okay. So here we go. So the next thing we need to do is we're going to go ahead and we're going to bring in our Lambda function. Now, I'm using the Lambda function, number one, to compose the actual prompt. When you're using LLMs, the prompt, it's really important that you get the prompt right? And so I'm going to use the Lambda function to construct that, and I'll show that to you in a little bit. But I'm also, because I want streaming, I'm also using Lambda to make the request in a streaming response. So let's go ahead and bring in our Lambda function. All righty. Okay, so we want the Lambda invoke, and we'll just pull it down here. Now, the cool thing here is we're going to do a couple things. And actually, when I go back to parallel, there's one thing I want to do here. And I'm going to go back and make sure I get my settings right here. So in my parallel, I want to output all the data into this. I want to, instead of the way step functions works is you can just overwrite, but I want to output all my content into a new parameter. So I keep everything, and this will be the content results. Okay, so that's the one other thing I want to do. So let's save that. Okay, so it doesn't like that my Lambda doesn't have any settings, so we'll do that now. Okay, so with the Lambda function, I need a function name. Well, again, we're going to just use this this definition substitution. So we'll go ahead and we'll just call this a prompt function. Okay, and there we go. Payload, everything else here will stay the same. So that should be all I need there. And then our output, we're going to make one change. Okay, so we go up here to our output. In our output, we're also going to add this. We're not going to filter. I'm just going to leave that alone. I'm going to add it to the original output under something called full results. And I'll explain that in a minute. All right, so we save that. Okay, so we're almost done. The very last thing we need to do is we now need to save our data. And then I'll walk through all this in just a minute. So we're actually going to do a dynamo. This time we're going to put an item. Okay. Now the nice thing here is this will look very, and I actually probably won't fill all this out. I won't make you watch all this because I'll bring it all in a little bit. But you get the idea. Okay, I can go in and fill out the table, stuff like that. All right, so let's walk through exactly what's happening. Okay, so first of all, you're coming in, and when we get to this parallel state, we're going to, at the same time, grab any history based on the connection ID. So if you reset it, then it's blank history. And we're going to grab any related data out of Kyndra. Okay, then we're going to pass all that data into a Lambda function, which we'll walk through in just a minute. That Lambda function will create the prompt. It'll make the call to Bedrock in a streaming format. And then what it does for every chunk that comes back, it's going to send it to the connection endpoint on the API gateway we created with the connection ID. So if Brian sends something and I send something, we each have our unique IDs. So it can answer Brian and it can answer me independently, never having the two cross, right? And that's pretty much the idea. There's a couple things that I want to add here before we get into the Lambda. One of the reasons that I choose using step functions is I want to be able to handle error control at step functions level. I am not good at writing error handling code, right? Okay. You know, I said I can do it, but it's not pretty, right? So instead of me having to do that, what I'm going to do is I'm going to go ahead and go into my Kyndra, because something we need to know about Kyndra is Kyndra can only handle about 1,000 characters in a research. If you put more in the prompt, it'll blow up, right? So we want to kick that error back out. All right, so what I'm going to do is I'm going to go ahead and in step functions, I'll pull this over so we can see a little more. Okay, you have an error handling tab. Okay, now I can add, and we'll talk about some retries and stuff, you know, we can add that later. But what I really want to do is I want to do a catch at the moment. Okay, and so what this is going to do is we're going to do a catch, and we're just going to say when too long, just for the moment. See you later. You made it as long as you could. All right. She just came to study and got stuck with us. So she goes, I'll stay and check it out. So I said, you probably won't. So, all right. So, all right. So what we have to do is we're going to come in here and we're going to say when this is a Kyndra.validation exception, then I want you to do something. Okay. And what I want you to do is I want you to go to a new state. Okay. So we're going to add something. So it watches for these errors. And the last thing I'm going to do is I'm going to say, add the Kyndra error information to a field called Kyndra error. Okay. So what this does, let's see what we have at the moment, is it creates this branch that says, hey, if this fails, I want you to do something. And what I want you to do, well, I want you to do, let's do an invoke. And that should be, here's API gateway. We'll put it on that branch over there. I want you to call API gateway and say, hey, this didn't work. Right? And what that looks like is we actually, again, we'll use our, let me pull this over so we can see it a little better. Scroll up here. I'm all zoomed in, so it makes it hard. So basically we're not going to send any headers. Maybe not. And I won't fill all of this, but I want you to see some of it. Okay. And we're going to modify the path, and we're not going to send any query parameters, but we are going to send a request body. So basically what we're going to do is we're going to say, let's grab the WebSocket API, right? And we'll just use substitution definition. And then we're going to grab the same here. We're actually passing in these. We'll do the WebSocket stage name. And then finally, for our path, we're going to use a step function's intrinsic function called format. It's going to be states.format. And then here's what it looks like. We're actually going to say, we want you to take the connection endpoint, so it's connections at, okay, and then we're going to pass in, I'm sorry, it's not at, it's at connections. This is why I have a cheat sheet. I can't memorize all this. Can't even remember my kids' names. Okay. I was telling somebody earlier, I have 5 kids. Their names are 1 through 5. So, all right. So the next thing we do here is we say, okay, we want to replace these curly brackets with that connection ID that we have in the data. Okay. So what this says, okay, I'll create the string out of that. I'll add the stage name, the API, and I'll create this endpoint. Then I'll pass the connection ID, and I can return an error to the user, so they're not wondering what happened. Okay, so we could do the same thing. So that's doing it on the actual Kendra search. Let's zoom in here. Was I? I wouldn't. It wouldn't be unlike me, Brian. Let's take a look here. Oh, I sure am. Good call. Nice. There you go. Yeah, I got no pride in this. Thank you very much. All right. So Brian is infinitely a better developer than I am. Good catch. Okay, so let's zoom in. So now we want to do the same thing with a Lambda function. This is where, again, well, you're using a Lambda, but I still want to take the power of step functions, do my retry. So if you'll notice here in the error handling, the retry, we already have one retry built in. Okay, it's automatically there, and it says, hey, if any of these errors happen, we're gonna try every 1 second for up to 3 attempts with a backoff rate, and so on. So it will retry for you instead of me having to write the logic. Originally, I was doing them like, this is horrible, but it'll handle that for you. So the next thing we wanted to do is we want to actually add a catcher on this one as well. And we're just going to say, look, we'll pass this in. This will be the Lambda error. Okay. Wow. Lambda error. Okay, there we go. And what's that? Did I miss it? Do you think it needs it? All right. Don't tell Chris Munns. Chris Munns used to be my boss. If you call Lambda functions lambdas, he would probably fly to where you are and abuse you. He gets so frustrated. All right, so Lambda error. I could say Lambda function error. All right, and then what do I want it to do? And we say, we're going to, on this one, we're going to say, we lost the signal again. We'll wait for it to come back. On this one, we're going to say, if anything happens in this one, we want to go ahead, and this is where I just filled this in, states.all, anything happens, we want to catch it. This is after the retries. Let's go ahead and catch it, kick it out, right? So the fallback state is we're going to go ahead and add a new state here. Let's, and then what we're going to do, let's save this so I have the save. We're going to take this guy, we're going to duplicate this, drag it down here, update the text, and that's error handling for both the Lambda and the Kendra. And I can add more as needed, but this, Eric, who is a slow coder, did this in very little time, right? So, all right, so that's the step functions part of it. So I'm going to save this. We're going to eject out of this, and I'm going to show you a couple things that are kind of cool. If we look at the step functions details, we now have some more definition substitutions. For instance, the context table. Right now it says, hey, I don't know what the context table is, but I know I'm going to need one. So that's blank. Same with Kendra ID. And actually with the Kendra ID, we're just going to say, we're going to pass in the Kendra ID in the parameters. The prompt function will connect up. Let's go ahead and get some stuff in there. So first thing we're going to do is we want a DynamoDB table. Yeah. Yeah.
Just a quick question. So the existing retryer in the Lambda is just the default operation for any kind of Lambda, right?
Right. That you could turn it off, of course. But yes, when you drag a Lambda in, that's default.
Okay, so that Lambda is not special because it's in step functions. If you were to create outside step functions, you would have the same kind of.
No, it is a step functions implementation of the Lambda function.
Okay, when you drag it, it has a different.
There you go. Well, it's the Lambda itself. So think of it this way: the Lambda itself is the same outside, inside, doesn't matter. The step function is reading the response from the Lambda and building this retry logic around it. So it's saying, oh, okay, I got a 500 back, a service error. Go ahead and retry. But it's it's entirely step functions that are doing that.
Doesn't Lambda outside the functions have like a regular, like retries twice, right? No?
No.
No.
Yeah, you write that in. Yeah.
It's always the integration.
Right, exactly.
So if
SQS.
is just a function, but all the integrations are going to call the function and say, oh, okay, it worked or didn't work.
Okay.
And so it's the integrations that will retry. It's not the
So
function
maybe
itself.
API gateway in front of it or something.
API gateway will not. SQS, it's usually asynchronous services. SQS, SNS, Event Bridge, those kinds of things. API gateway will just throw back. API gateway connects to Lambda 99% of the time. We can talk about the other 1% at some point as a proxy, and it basically says, "Here's what I got. Here's what you returned." It does no work on it. So obviously you can add auth and stuff in front of it. Okay. Call it out if I have more questions. I'm looking down. I look down when I type. If you're in a meeting with me, this is all you see. So yeah, please call me out. So, okay. So we need a DynamoDB table. So let's go ahead and drag that on. Let's name this. We can say context table. And again, we won't go through all the formatting, but we know that we want a PK. It's going to be a string. We know that we're going to have an RK. So what I said, PK? Yeah. So no, SK. RK. I don't even know what RK is. Range key. Okay. I just make up things. Number. Okay. So that's my table. Now here's kind of cool. Watch this. So I know the DynamoDB put item. I'm going to go ahead and drag it there. And it's not going to work here. Hang on just a minute here. Okay. Did I not get one? Let's save this real quick.
Does it have to match the exact table?
So it usually doesn't, but let me check real quick here. So let me go ahead and check my thing here. This always works when it doesn't matter. Okay, so there's context table. So let's see here, context table. Oh, I think I know what's wrong. Hang on a sec. No, it's because remember I said to you, well, we won't fill all this out. I didn't fill it out. So let me actually go into Workflow Studio. On this DynamoDB table, let's go ahead and make sure that we have context. And no, it doesn't have to match necessarily. It just has to be, wow. Okay. All righty. There we go. All right, so we can save this now. Now, when I go ahead and exit out of here, I'm going to drag this. Now, we made the connection, and yeah, it does the cool thing. It goes ahead and wires up that. You can see here, context table. It's got a mapping to that. But there's some other things going on that you need to understand. Anybody know what IAM is? I call it IAM. People make fun of me. Okay. Yeah. Identity and access management. Raise your hand if you love it. Yeah. I'd rather do Coors. Not Coors the beer. Coors like Coors, right? If you know what that is. You know what I'm talking about. Yeah, IAM is hard. It's, what's that? Or CSS, or VTL, right? IAM is hard, and it's just because identity and access management is hard. I think we've done we've done a great job of making it accessible, but security is hard. So what we do is we go ahead and wire up the step function with least privileges that it can read or write from that DynamoDB table. And we make those connections for you. In fact, if you look at the template, it's actually building the template under the hood. It's very verbose, and it's not terribly pretty, but it's all the sand that builds this up, right? Okay, so that's one of the reasons that we use these definition substitutions, that we use these connectors, because it builds the right permissions for that. So let's go back to our, yeah.
Is it smart enough to know that in step functions you're only reading from the DynamoDB table, so you only use it a read write?
Not as of yet. You can certainly go in. It usually gives it a CRUD. So create, read, update, delete on that. But there, you could certainly bring that down to look. This step function is going to read and write. So I don't have a need, because it's actually reading from it front, writing to it at the end. So I'm good with the CRUD, right? But I can actually scope that down pretty easily through the policies. Yeah.
No,
Yeah.
so by default, so it's not really this privilege.
I'm really hard to hear you
Right,
say.
so by default, it's not really least privilege because it's just giving.
Yeah, you caught me. Yeah. It really, that's a good call. It is in that it's not going to give you access to create a new table or things like that, but it is read write. That's a good point. Yeah. Some of them, like if a Lambda function is connecting to just read, well, it doesn't interrogate your code, so it doesn't know if you're going to read or write. So that's kind of where it's at. But again, you could scope that pretty easy with the policies. So good call out. Really good call out is basically what he's saying is, everybody in here gets it. So, okay.
One more thing, real quick there.
Yeah.
What about when you have resource policies? Is it smart enough to figure out like, KMS, SQS, maybe playing a game of IAM resource policy?
Maybe, which is a solid yes, solid no, depending on what it is. It depends on what they've built in. A lot of them they have. I drag on SQS. Yes, it's going to handle that. Some of them may not be supported yet. This is a fairly new product. It is GA, but they're building on it very fast. So a lot of things are just standard resources that just show up, much like this standard component down here. So
Fair enough. Resource policies are hard, so I was hoping.
yes, they are. Yes, they are. Yes, they are. So okay. What? Yeah. Okay. So the next thing I need is a Lambda function. So I'm going to drag that out. We'll go ahead. Now this is kind of cool. I'm going to go ahead and call this my prompt function. You okay on time, Brian?
Yeah.
Okay. Maybe. Okay. I just keep it in the source file since that's the only one, or source directory. I'm doing Python 3.12, and I do an ARM architecture. My handler's fine. I don't need anything else, so I'm going to save that. And then I'm going to do the Lambda invoke. Go ahead and drag this here. And now it connects it up, and it does all those same permissions. Okay. So pretty much we've built everything. I haven't wired everything together because I'm not going to make you watch me do all that. So I'm going to, of course, I'm going to close out of this and use the magic of GitHub. But I do want to show you, here's everything in the SAM template. Here's everything you need. And I can actually do SAM deploy, and it won't work because I haven't wired everything up. But SAM deploy would deploy all this. All right, so let's go ahead and let me clear out this. So I think the fastest way to do that is just revert all this. There we go. All right, and then we'll switch over to my main. And this main that I have is actually a public repo that I'm gonna share with you all at the end. It's the same thing we just built, but everything's wired up, okay? So if I were to pop this open, it looks very similar to what we just did, except for now the prompt function is talking to that API because we have the permissions. All right, so I want to go in and I want to show you the Lambda function itself and how that works. Here we go. Apparently I did have it under function. Okay. So in the repo, when you do this, I added a lot of comments so you know what's going on. Now, I'm wide open to someone going, there's a better way to do that. Again, I'm an architect, not developer, but basically what we're doing here is I'm doing a couple things, okay? So here's my handler. I'm grabbing all my information. I need to know the model ID, which I pass into an environment variable. I need to know the Anthropic version because I'm using Anthropic Claude. I need to know the tokens. I'm passing all that in via variables. And then I grab the data, the results that I explained to you how they're being passed in. They're being passed as an array. I process those through a function. And so the Kinder results I grab and I process them. And then I grab the history and I process them and I get them all together. And then I prepare. This is the request that I pass out for the. I'm sorry. This is for the JSON body. For the body of Anthropic. Okay. So then I'm going to call, and I'll show you kind of what I'm doing here. This is the process response. Let me go down to the generate system prompt. Claude is an interesting. I'm gonna stand up for a sec. Claude is interesting. The newest version. Oh no, I'll stay where I am. Sorry. So. Claude's really interesting because it no longer is just a user. Now you have a system prompt and a user prompt. And so the system prompt, you kind of tell it, hey, here's what you are, here's what I expect, all that kind of stuff. And then the user's just coming from the user. It's kind of built for this idea that we're building stuff on top of it, right? So, so that's what we're doing here. So this is building the system prompt. Now, I literally asked Claude, hey, Claude, if I wanted you to read from the RAG implementation, how would that prompt look? And this is the prompt it gave me. For this query, please prioritize the context I will give and try to ground your responses as much as possible in just that information, including links where possible, minimizing pulling from other background knowledge unless absolutely necessary. The context provided will be in the form of docs provided on the topic and a history of questions and answers. If you don't know the answer, say, I'm sorry, I don't know. Return all answers in Markdown. This is so my client can read it. I was trying to format it all, and then it was like, oh, Markdown. All right. So that's the prompt. So you're really kind of setting Claude up to know what the expectations are. Okay. The next thing I do is I load up all the docs. I actually iterate through all those and put them together. I load up any history, right? And these are the two functions that process that. And then I go ahead and I send the data to Bedrock. And then what I do is as those come in for each chunk, I actually call the API gateway through the SDK. Actually it's this one here. I call and I send back that partial chunk. So this is my faux, how do you say that word? F-A-U-X, faux, okay. This is my fake, I'll use that. This is my fake streaming, right? So I'm actually sending it to the WebSocket over and over, right? And then I'm also saving the full response because I need to save that to the database. So I'm collecting all that up. When I get the ending call, I send an ending call through my WebSocket to let them know, hey, this is over. And then I kick it back out to step functions, and step function saves it to the database. And that's it. So before we do the demo of it, what kind of questions do you have?
The SAM template, is it taking care of everything except for this code that we're seeing?
Yeah, it's even taking care of this code in that it's bringing it in and zipping it up. SAM does that. The only thing it's not taking care of is the Kendra indexing. That's pretty complex, and I felt like because I was sharing this, it might cause some issues. So in the instructions, it tells you, hey, go create a Kendra index. Good luck to you. And then come back with an index ID. And that's all you really need is an index ID, right? Other than that, it's creating, and you have to enable the model. You have to do that anyway. So you enable the model. Once that's done, then it sets up the API gateway. It sets up the step function, the Lambda function, the connection to the Bedrock, everything like that. So, yeah. What else? Yeah.
At some point, you're going to overflow your context window, right?
I am.
Are we worried about that now, or?
I kicked back an error. Do you remember I did error handling?
Okay.
So yeah. So what I did there, I only did it at Kendra well, really there's an error handling, but I did a very specific error at Kendra because I did it like 3 times. Like, what's going on? Oh, So I'm not going to take time to add a bunch more in front of y'all, but I could add different ones. But basically what I said is, if Kendra kicks back this specific error, kick it out. If Bedrock kicks out any error, overflow, something like that, kick it out. One thing I'm not doing here is I'm not doing any kind of provisioned on Bedrock. So I'm getting, exactly. I'm getting 429s once in a while. So I kick that back out, said, hey, it's busy, try again later. So that's where the error handling comes in. Again, I'm doing the states.all, so I'm catching but I can get more customized. Yeah, I can get real customized. Absolutely, yeah.
I mean, this is a question about Bedrock, so that's on demand, right? So you have to do anything.
Right. So yeah, I'm just calling the API. Yeah, over and over. So on my account, yeah. Sir.
So you're using express step functions, right?
Yeah.
Isn't that limited in time, like to however many minutes?
5 minutes. Good call out. Yeah, I feel like it's the step function only runs as long as one question, and then it goes away. And so I could run standard, but 2 things. Step functions runs, that's because my laptop has gone to sleep here. Step functions runs in memory, Express runs in memory, so it's pretty fast. And it's cheaper. I could do standard, I didn't need it. You're saying
the step function just runs and goes away. It doesn't stay for the entire chat duration.
Right. Every time you ask a question, it invokes a new step function to do all this and goes away. So it's very ephemeral.
So all the context is taken in DynamoDB database.
That's right. DynamoDB saves the history of the text. Kendra has the context. Does that make sense? Okay. What else? All right, y'all want to see it work?
Demo.
What's that?
Demo.
Demo time. Okay. All right. Now, I'm going to be straight up. Eric is not a designer either, so don't make fun of my design, right? Okay. So what I want to do is I want to show you, I've got 2 links on this here. So this is Ask Claude. This is everything we just built except for Kendra. This is literally just saying, hey, whatever they ask Claude directly. So if I come in here and I say, what is EDA? Okay, we'll go ahead and ask that question. So I got this prompt. EDA, exploratory data analysis, refers to the process of analyzing blah, 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 blah. I won't read all that to you, okay? So this is what Claude knows EDA to mean, okay? So however, if I change it to serverless land, okay, now I'm going to ask the same exact question. What is EDA?
And this is overloading the request to Claude with all the Kendra.
There you go. That's a great way to say that. Yeah, my mic just popped off. Sorry.
And while we're doing that, do people know what Kendra is? So, I mean, overall, I mean, at a high level, I would say it's your own personal little web indexer.
Yeah.
So you point it at a site, it will crawl that and index your content at a very high level.
Yeah.
All documents.
Or
Oh, well, no, or very deep. Yeah, it could go
Yeah.
incredibly deep. It's pricey. And for good reasons, doing a lot. So don't just, hey, I'll throw one up there. There's a community version you can use. Use that. I'm actually running the enterprise. I'll probably go back and switch that before I get fired. But yeah, but there's a free, everything I've got here, there's a free tier for. But it actually could go, there's a bunch of different connectors, Salesforce, Oracle, all kinds of things that you can index, including S3 buckets. So I chose to do serverless land because that's where all this data was. All right, so let me ask serverless land, same thing. What is EDA? Take it a little longer. Event-driven architecture. Event-driven architecture is an architectural pattern that involves the production. I can't read that fast. So it has used serverless land data override its domain specifics. And then I can come in and say, show me a SAM template example of EDA. Okay. So now, I should have said just show me a SAM template of it, but it's contextual. It knows what I'm talking about. Okay. So here's an example of an AWS SAM. So there's your SAM template. You could copy this and deploy it. Okay. Not terribly impressive. Claude could do that on its own, but it's grabbing this data from serverless land to build that out. Okay. So again, this is your context specific. So you could point Kendra at, like has anybody ever heard of, yeah, don't make fun of me. Has anybody ever heard of Winglang or Wing? Okay, good. I talk about it all the time. Brian laughs at me because I think they're pretty awesome. But I can't for life, I'm not a smart enough developer to figure out their technology. I'm not smart enough to understand structs and you know, all that kind of stuff, right? But the guy who's created, his name is Eli, he's a good buddy of mine. I called him and said, or I texted him and said, hey, give me your sitemap. I'm going to add a new one of these. It's going to say Ask Wing. And I'm going to have it put together code examples for me based on what they're doing, right? So it's very powerful in the approach. Now, real quick, if y'all want to play with this, I'll go ahead and throw this up. So this is the chat. Now, this is going away in a few minutes or probably tomorrow morning. But if you want to throw this up on your phone and play with it tonight, you can look at it and see. It's not the best mobile experience. Sue me. I'm not a developer, okay? Right? You want one, you pay for it, okay? No, I'm just kidding. I'm going to be really honest. Claude helped me build most of this interface. So it's very powerful to do that. All right, so now's the time. I have a couple more things I'll bring up, but what kind of questions do you have? Yeah, right here.
When you're building this for a customer professionally or something, what's your next step? Are you caching, more security? What's next? So
caching is probably not the right angle because again, it's I've forgotten the word. Stochastic. Stochastic. It's undeterministic. Yeah. So I don't want to say, and what a chance of asking the same exact question. I want the LLM to generate an answer every time. So I probably won't cache. However, the next thing, there's several ways that you can prime an LLM, right? One is I can do, instead of using Kendra, I can do embeds. I can do an embedding model and embed all this data. And then I can do the same model to grab that data. So tell me the closest to this, and then give it to the LLM to build it. So it's basically 3 models I'm going to use. One is the embedding, and I'll just embed all that stuff up front. The second one is at the time of the question, I'll do the request and get those back out in paragraph form and inject it into my prompt. So all this is kind of pre-prompt stuff or prompt chaining. You can certainly do that. Then I think what I'll do is I'll probably do, so I'll add that, and then I'll probably be doing some of the agents. So what I would love to do is say, hey, if you recognize that they're asking for a picture in here, so the LLM has to recognize that. So I'll just tell it, if you recognize, then run this task, kick it over to stability or something like that, create the image, and then kick it back out. So those are some of the things. And I would love to see architectural images come out with these same templates. So does that answer your question? Yeah. Right here?
Yeah, this is probably my lack of knowledge of Kendra, but like, I'm assuming that the data for service land is pretty big, right?
It is, yeah. I'm only scanning 2. We have broken down sitemaps for different parts. I'm only scanning 2 parts. I think it's the patterns, which there's 900 and something and a pattern is literally a full example, and the EDA stuff. But there's a lot more. But yes.
So, how come you're not running into the step functions like payload limit when you go from? So Kendra is not returning all that data, right? What is it returning? There's like step functions is some kind of a limit.
It does, yeah. 256K in the transitions. That's right. Yeah. Okay. It's testing. You don't know. No, just kidding. Yeah, 256 for passing around. So something that Kendra's doing is it doesn't pass back the whole document. It passes back the pertinent parts. And that's one of the things that with your embeddings, you would do it the same way. You don't just drop the whole thing here. You drop these. You can break it down. There's math that I don't understand. But so what's coming, and that's also why I'm limiting it to 60 responses. So I know with 60 paragraphs, I'm staying under the limit right now. If I start hitting that, then I'll have to tweak that a little. Does that help?
So that Kendra request, so the request comes in from the UI, it queries Kendra, and you get 60 paragraphs back.
That's right.
And those 60 paragraphs go into the
That's right. You want to see them?
API.
Yeah.
So those 60 paragraphs, they're under 256K.
Hopefully.
Yeah, up to 60. So maybe there's not 60 paragraphs on who is Eric Johnson, right? So this is the step function after it's run. Okay. So we had it run. It did those 2. There were no errors, so skip by. It did Bedrock in here. So the return from here's Kendra. Here we go. Did we lose? This is crazy. Hang on a minute. It'll come back. There we go. So this is what it looks like. So here's my result items from here. And so let's just kind of go through until we get to one. All right, there's one paragraph. Okay, there's the document ID, some highlights. It gives some importance there. So there's it here, and then some information I don't understand. And then we come down. There's another paragraph. So there's a lot of data here, right? So I could, if I felt like it was getting too big, I could kick this out in another state machine and clean it before it comes back in. So I could do some work on it. There's a lot of data getting passed back that I really don't need. But so I could do a subtask that call this, do all this, return it, then continue. So I could. That's another way. I could get in and do the result. I hadn't had to do that yet, so I just kicked it all in. But you're right. I could actually format the results, but it might be easier to do it external. I don't know. But yeah, it's pretty deep text, but yeah.
There's a little prompt in here. You can probably get it to return those document URLs. So if people want to.
You can actually, and it's kind of surprising because in my prompt, remember it said return links where possible. Sometimes it does, sometimes it doesn't. Exactly, it's not a perfect science. It's really interesting. We had another question. Yeah.
Is there a temperature, like with ChatGPT, there's a temp, right? You
Yep.
Turn it up and down. So does that work the same?
Yeah, it does. So you can actually it'd be in the function. I can actually add a temperature. I just left it blank, so it's default temperature. But I can randomize that. I can change how much it responds, things like that. I left those all default, but you certainly have that kind of flexibility. So yeah.
I just had a question. You said, is Kendra vector doing this or not?
I don't believe it is under the hood. I don't think it's doing vector. I cannot say for sure. I believe it just stashes it all as text, but I don't know that for sure. So, great question. If you're not familiar with the vector database, that's the mathematical equation of that would be the embeddings. So if I were embedding, it would take the paragraph, do a mathematical equation of that, put it in, then that's how you know it's close. So.
Are Claude and Kendra together?
No, they're two entirely different products. Kendra might be
I'm
using
just
cool.
joking. It sounds
Yeah.
sounds
Oh, it's like a dating story. Yeah, exactly. Yeah, AI dating. Yeah, I get you. So yeah, he's got to go. So, he's stumping me. That's two.
Two strikes.
What else?
And the vector, switching to vectors would be the more grown-up version of this. Like as I know what I'm doing,
Yeah.
maybe I start
Yeah.
here, figure it out.
Yeah.
And then once I know what I'm doing, I switch to more of the vector database.
Yeah, and it might be interesting to even use Kendra to do the identification of pertinent paragraphs and but yeah, embed. I've not done embedding yet, full disclosure. I don't have that answer for sure, but yeah, Kendra is it's used by a lot of very large companies out here. It's very powerful, but yeah, embeddings.
I can answer a little bit on that. So a lot of times customers start with Canva because it's like no code. You can shove your documents or like crawl your website and index it. But then the natural progression from there is going to like something like OpenSearch. This has a vector data store.
Right.
Because then you can use like a embeddings model to generate embeddings from your data, store those embeddings in a vector store, and it could be like OpenSearch, it could be PG Vector, it could be like Aurora, it could be any of these, right? What have you? If you have something already going on, you ideally use that. Obviously, there are performance and price trade-offs, but from a no-code point of view, it's like very easy to use this. The next best thing to use after this is OpenSearch serverless because it's also very easy to use. So if you want to go down the vector data store route, like pure vector data store route, try OpenSearch serverless because it's like easy.
Yep. Embeddings are really interesting because you have like Titan embedding model, and then the Titan model can read those, and so it's kind of interesting. What else? All right. Anybody wanting to build one of these?
That's pretty cool.
Good.
Yeah.
Good. So on that note, then what I'll do here is if you want to take let me bring this up so you can get a good picture of it. This is the code. No, that's not the code. This is the code. So what? You got to be faster. I warned you it was coming. All right, here we go. It'll come back up here. s12d.com/chatbot. Just a point of interest if you're interested, or if you're not, I'm still going to say it. So there you go. S12d.com is nothing but API Gateway and DynamoDB and VTL, and it's super fast, super reliable, and nobody understands how to fix it. So it's pretty cool. That's not true. I work on it. It's something I built a long time ago, and we actually use it internal at AWS for shortcodes. And it is. I say reliable. Tomorrow it's going to go down, but yeah. So.
What does the 12 stand for?
So serverless land. There you go. Good job. I got to be honest. I never knew what K8 stood for. I'm like, that's what? How does that work? And then someone explained serverless land S12D. I'm like, because they just told me get the domain. Oh, okay, I'll get the domain. Oh, okay. 12 letters in. Okay, gotcha. So there you go. All right. With that, I'll just say thank you very much. I appreciate your time. We'll obviously be hanging around, and I'll answer questions and probably kill the stream.
All right.
Yeah.
Thank you.